Hey everyone, welcome to the Research Jam. Full of new folks today. So just checking on for just 1 or 2 minutes more. If anyone else want to join in, and yeah, then we can get started. Yeah, I guess like everyone is here, so Ishan, you can get started.
Yeah, just let me share my screen.
Cool. Yeah,
Aman, you want me to start or you can wait for a minute?
we can start. Like we have around 10 folks, and yeah, we can start. Anyone wants to join, like they can join and get that.
Okay, sure. Are you sure there in the meet, right?
Yes. Hey, hi everyone. Thanks for joining. We can start. So, welcome to Research Jam Session 5. We are discussing ReasonIR, training retrievers for reasoning tasks. Next slide, please. So, quick introduction on us. We help enterprises build domain intelligence seamlessly and get the benefits of unmatched cost control and performance in three simple steps, which are ingesting your data, creating, maintaining and improving your LLM, and then integrating in your LLM application. Next slide, please. So research is definitely a very important aspect for what we are doing. We are continuously on the hunt for papers who are, giving us new ways to customize LLMs, new ways to incorporate business knowledge or control them, and new open weight LLMs that are available with time. And so we started building an internal tool for ourselves called the LLM Research Hub, which could, source multiple papers across the board and then rate them by relevance to our field, the quality of the paper, the popularity and impact that it is having. And we thought, like, why not just make it available as a tool for the general audience? So that is what LLM Research Hub for you is, and has the best papers in a particular given period of time, and those are the best papers that we actually pick to cover in this research jam, to discuss internally and also to have an engaging discussion outside the community. Next, please.
Okay.
Right. So we've had four um, jams already. The SUI-RL was one, then transformers without normalization, small VLM, and then LLMs are greedy agents, and now we are on to our fifth. So on over to Ishant to start
Okay.
discussion. Thanks,
Okay.
Ishant.
So, yeah. Hi guys. My name is Ishan. I'm also from Genloop, and this edition of our cognitive generation. That is, how do we train RAGs for reasoning tasks? So, with the advent of many reinforcement learning algorithms, we now have a bunch of reasoning tasks that have been opened the doors to. And as a part of it, now you need to train or you need to have models that are able to, complement these reasoning tasks. And in the domain of RAG, we need to have good retrievers that are able to fetch and provide us relevant information. In part of this, the Facebook and AI research group, they have introduced ReasonIR. IR stands for Information Retrieval. They've developed an 8 billion model, which is the first bioencoder retriever that is specifically trained for reasoning intensive or complex reasoning based information. And they show superior performance and even state of the art results on information retrieval and track benchmarks. So आज का जो ये होगा that will be covered mostly around information retrieval and RAG and how this the system has provided new benchmarks for it. I'll just cover the background. So I'm sure everybody is familiar with RAG, but just to be on the same page, RAG essentially stands for Retrieval Augmented Generation. So LLMs in their own state are stateless essentially. They don't have and they don't have any access to external knowledge unless we provide them such. So tools and external context that is fetched from these retrievers are one of the ways that LLMs have knowledge to the open world domain. And for the usual queries, for simple queries, direct factual lookup is simple. जैसे हम Wikipedia खोल के हम simply पता करते हैं कि ये movie कब release हुई थी और इस movie में कौन सा cast था. But for many complex or reasoning based tasks, the prevalent state of the art benchmarks on they don't account for reasoning intensive tasks. So that is what I'm trying to address here. Existing retrievers, they are trained on queries that are really small and straightforward. As you can see, there are two common databases that has natural questions and MS Marco. They both have close to 20 to 21 tokens average. And now as I said, get me the year in which this movie was released, or get me the founder of this organization. So these are more or less straightforward tasks. And for this you essentially have to look up the document, and the document is pretty much clear. Now enter reasoning intensive tasks. These are not so straightforward tasks, and require some intuition and good thinking abilities. And for this, direct looking up of facts, that is not possible. You need to have good you need to fetch good data. So I've put here, for example, there's background knowledge, there's methodological frameworks as to how to approach a problem. Suppose you're given a problem of integration, so it has to know a few rules that it needs to apply, and a few tricks that it can use to solve. And like I said, analogous problem solving patterns, उसको कुछ तुम initial or existing examples दे सकते हो that will just initially help it to understand the problem. So background knowledge is pretty much important, and so is the methodological framework. So when I say reasoning intensive tasks, we need to have a system that is able to fetch us this type of knowledge. And the other aspect of reasoning intensive tasks is that in many of the times, to chat gpt or to Claude or to Perplexity, we don't trust its raw power so much, so we try to expand the query or refine it or simple it or simple it or dump it down as much as possible. So this results in longer queries. Now the problem with current systems is that it is able to process queries that have lesser tokens. But आप जैसे tokens की value बढ़ा दो एक query में, suppose on the Bright benchmark, going forth, Bright is basically a benchmark for reasoning intensive information retrieval. Okay, so आपके normal तो होते हैं, but Bright is for reasoning intensive information retrieval. So those queries have like 194 tokens per average, which is a very big value. Though, so the problem is that the current models and current retrievers, they're not able to fetch, or they're not able to extract or utilize the information or the deep information enriched in these long queries. So that is the reason we have to develop a system that is first able to identify contextual or reasoning based knowledge, and second, it should be able to utilize the length of these queries, the depth of these queries in a good way. So this is the
just quickly on the last one. When we say retrievers, existing retrievers are trained on data sets like natural questions. So how many retrievers are just embedding match? You have a chunk of embeddings and you just retrieve the document based on that closer similarity. So when you're saying retrievers training, what exactly are we talking about?
Yeah, so you consider the retriever BF25 or even dense retrievers. The data, or even dense retrievers like I don't remember the name exactly. Just let me come up with the name. Grid 7B. Grid 7B हो गया, even OpenAI के हो गए. So that either they are sparse or dense, but the common thing with them is that the data they've been trained on, majority of the data that had queries only 20 to 30 tokens. इतने in-depth queries नहीं थे. That was the initial problem with it. Like I gave you the examples, and suppose you provide it with a much denser query that has much more information. So the query is not the retriever is not able to extract or utilize the important aspect of it. It misses out on a lot of information, and due to that, the retrieval is very poor.
Sure. So I just wanted to double click on what training is. So one training is that, okay, you are training the embeddings on that. Like
Yeah,
embeddings form a
yeah,
very important part of retriever. So one training is you're talking about the embedding trainings. The second is the hyperparameter setting or the tuning of the pipeline. What should be the chunk size, what should be the threshold for retrieval, what should be the metric that we're using for finding the best
no.
match. So
I'm talking about the former one, the first training. Essentially, so let's get into fundamentals here. I'm talking about contrastive learning. So the
yeah,
way through which these are trained. So that is the one I'm talking about. So many existing retrievers that they're trained through contrastive learning. So given a query, you should be able to match to the positive documents, and at the same time, you should not match to the negative documents, right?
hmm,
So
hmm.
maximize true positive and minimize hard negatives. Sorry,
This year,
false negatives.
all the embedding trainings.
Yeah, this is for the embedding trainings. So this model is essentially a retriever model, right?
Got it. So
A
this is
bioencoder retriever. So given a query and a document, it'll try to fetch the similarity basis.
got it. Cool. So this is about, so we are seeing the dense retrievers today, which are basically like embeddings that are available in Hugging Face, like the MSC one or the embeddings from OpenAI. They are not able to do good enough job when a reasoning task is required, and reasoning task could be, multiple things. It might be speaking
Right.
about maybe the document is about Donald Trump, but this is speaking about, oh, tell me the 41st president. So there will
Exactly.
not be any semantic match because this is just an NLP match. There's no reasoning task there. So we are
Yeah.
saying that how can we train the embeddings, which are the core part of the retriever, better for reasoning tasks.
Yes. So essentially, when you retrieve given a query, when you try to retrieve the documents, you should just not look for the semantics or lexical overlap. You should also use, like I said, you should look for background knowledge, which may
Right.
not seem exactly relevant, but a part of it is relevant. A chunk of it is relevant. Some frameworks that you should look for, and some, essentially PYQs or relevant questions that us analogous to the query we have at hand.
Got it. Cool.
Okay. Yeah.
And that's an
So
important clarification that this training is about the actual weights of the embeddings training. It's not about
yeah.
the fine tuning of the pipeline of retriever because embeddings are just part of the retriever process.
Yeah. So yeah. So uh, when we compare this in the future slides as well, I'll show you that how these perform with the existing BM25 OpenAI and the Flip 7B, whatever that was, the retrievers that were existing SOTA before this.
Got it.
Cool. Let me move forward with this. As you can see, to get a system like this, you have to have a good data engine or data generation engine. So the guys put up with ReasonIR Synthesizer. This is the essence of this research, and this is essentially a data generation architecture that is responsible for generating different types of data based on different dimensionalities. So uh, if you can see the green box consists of the data we already have at hand, which is the essential uh, uh, web search and all the usual things. The basically the first kind of it that has 2021 tokens average and that have simple factual lookup. So even for training a model from scratch, you need to have those for understanding the basic semantics, and they are like 1.3 million numbers. So you need to have those. Along with this, the innovation of this paper is VL and HQ. So VL stands for varied length. Now varied length, well, like I explained in the first point of reasoning intensive knowledge, sorry, the second intensive uh, task is that you need to have longer queries, and you obviously need to have longer queries, but your model should be able to process these long queries. And the existing models that we have at hand, they're not able to process these 194 tokens, or tokens greater than 150, if the paper I'm remember is correct. So what they have at hand was that they generated varied length. Now, by varied length, I'm talking from about 300 to 2000 normal words. They're training this so a two-stage process. And like I said, this is varied length. So for 300 to 2000 words, what they'll do is firstly, it will ask an LLM to come up with different task scenarios, and the scenarios that should have longer questions, or that should have elaborate questions and not simple questions, right? And so first you'll come up with a scenario. And pertaining to each scenario, you'll try to generate a complex query and a corresponding document. Okay, अभी के लिए आप एक query बनाओगे and firstly you'll find you'll create a document from that for the particular scenario, and then you'll create a complex query for that. Now the complex query मैं बताऊँ, मतलब इन्होंने, this is a fully open source project, so they actually release the prompts, the data, and essentially everything. So we can probably check that in the end as well. It's present in the appendix. So
And
this was
just a slide back, and I wanted to clarify and correct me if I'm wrong. Um, this reason IR synthesizer was one part of the paper where they're talking about the how they generated the training data, correct?
right. Yes.
And they're saying that today's public data sets are very simple queries and positive documents. But
Yeah.
a lot of the retrieval process requires varied length questions and hard questions as well. There's no data set for that. So they used
Yeah.
a system of LLMs to generate such varied length questions and hard queries as well. And the way they did that was definitely for hard queries. You mentioned in the next slide, it was about finding the documents that were reasoning worthy. I'm talking about the HQ first, the second point.
Yeah.
Trying to find the documents that were reasoning worthy, and through the LMs prompt them to find the core concepts, contextual things, etc., and wrap them as a user query. That is correct. That is how they
Right.
created hard query pairs.
Yeah.
And for varied length data, they basically what they do, they again selected, they could select
So
any document.
essentially, they thought of different task scenarios, or task scenarios where simple queries were not that usual. You need to have a holistic understanding of that particular scenario. So from that scenario, they generated a document, and from that document, they generated a query that wasn't such a simple factual lookup.
Correct.
Okay?
And the most
And
important one is this multi-turn hard negative generation.
yeah, the most
Really
important one is this.
have semantic overlap or lexical overlap with unhelpful chunks of the document, but are essentially coming from a different chunk of the document with which it needs a reasoning element.
Exactly. So that is precisely what I mean. So
Hmm.
for hard negatives, you should have documents that almost resemble the query but are inherently useless, or are not to be retrieved, and that is the reason they're a hard negative. And the way we generate this is conditioning on the varied length and HQ. So that is the reason if you see this for VL and for HQ both, the first step is to generate the positive document, and the second step is to generate the hard negative document. So, so what these guys found from experience was that if you initially give it a prompt saying that this is a document, generate a complex query and generate a hard negative document for this positive document, the quality of documents that you receive are really poor. So that is why the reason they used here was multi-turn. So the initial turns would focus at understanding the document and understanding the essence of the document. So that would mean the core domain concepts, the principles, the problem solving patterns and realistic applications of that particular document. From that, you generate a query, and from that you generate a hard negative document. So this was the way in which they proceeded. This was for hard query as well as for varied length. So they didn't initially start with just get me a hard negative document for this document. They let the LLM understand the document, the structure of it through a few turns, and then it prompted it to give a serious hard negative document.
Correct. So here the hard negative document is generated, not found. So it's not
It
part
is
of the.
generated, yeah.
It is generated, not found. Okay. Um, and possibly that is just a chunk of text, some tokens of text rather than a
Yeah,
big document, some chunk of text that is fundamentally unhelpful for the reasoning task. Okay. Hmm.
right.
That's interesting.
Yeah, so these were basically the three ways in which they tried to enrich the data. And as you can see, varied length data is to increase its effective context length, and hard query generation is basically to make it adapt to reasoning based tasks, right? So, and obviously the hard negative is to make it robust and to make it far from the hard negatives. Like the retriever should focus on positive documents, but at the same time stay away from negative documents,
Hmm.
right? And so this was a training methodology. So the base model that we have at hand is the Llama 3.18B base variant. and the model used to generate all these data in this page was Llama 3.170 billion instruct. I'm not sure whether it didn't go with Llama 3.3, even though the research is conditioned in April. Uh, but anyway, so since they were not using encoder-based models, they were using a causal model. So for those who don't know, causal models is basically you use some previous thing, you use some previous tokens, you condition your probability, and then you try to predict the latest token. So my name is, and basically this is the causal state of flow. And given that the token sequence is my name is, what is the probability that the coming token is Ishan? So this is basically causal language modeling, and all the modern LLMs they work on this task, which is next token prediction, right? So firstly, what they did was since Llama is the LLM that is trained on causal language modeling. The first step was to convert this the causal attention mask to a bidirectional attention mask. You do this because now you want to context. You want to you want the model to have access to the whole context, right? Not just the tokens before the current token, right? So you initially change the attention mask to a bidirectional mask. So to be precise, suppose you're on the 10th token, all the 9 tokens before it would be 1 1 1 1, and the next would be 0 because you don't want to have access to it. But in bidirectional, that is not the case. Okay. And the second part of it, which is the training means that I said, you have close to 1.33 million public documents, to 244K, not documents, queries, query and document pairs. And similarly for hard queries, you have about zero point 0.1 million. And using this, we try to train our model. And like I said, the model that they've questioned in this paper that is able to bring benchmarks, that is basically able to reach SOTA in both IR as well as RAG. So for IR evaluation, they use the Bright benchmark. So Bright is again, like I said, a benchmark for reasoning intensive information retrieval. And RAG, like I said, for RAG, they use MMLU, which is a very standard benchmark, and GPQA, which is graduate proof question answering, which is Google proof as well. And reader models, what I say, by what I mean is this, हमारा जो reason IR होगा, वो लाके देगा, and they have the query, and the reader models, we essentially process this context and query together. So, and the final state that they have with this is that the reason IR rank, which is a simple but effective tie-breaking LLM de-ranking method. Now, what we have, if you guys have experimented with existing RAG solutions, is that many a times when you ask a dense retriever or even a sparse retriever to come up with relevant documents, it gives similar score to many of the documents. So it results in a tie-making condition. So you have to make an order, right? So to make an order, you have to break the tie. So what it does is it it interpolates this present score with the previous score that you get from the retriever. So this is the re-rank step. But to break the ties, you conditionally add the score of the retriever step as well. And the retriever step in our case is ReasonIR 8B. So this is an aim to break the ties. And they use for this paper extensively, they use the re-ranker Quen 2.53 or 32 billion. So in the results we see in the next page, it is called as Quen re-rank. And like I said, there's no training needed over here.
Got it. Ishan, few clarifications here, and other folks can also feel free to chime in and ask for clarifying questions. One is when we're talking about the bidirectional attention modification, is just about undoing the attention mask, right? Nothing else needed to be changed in the architecture.
Nothing needed to be changed in the architecture. Just that the IR token has the access to I+1, I+2, I+N token for the attention mechanism.
Correct. There's a mask that is given to make it causal. You just undo that mask so that it is able to look at the entire context when creating the attention weights. That is all. Now, I also wanted you to please highlight what is the pipeline for retrieval with ReasonIR 8B or generally with the kind of mechanisms that they are saying. I'll elaborate. For example, the earlier retriever pipelines were, or one of the retriever pipelines are that for a document you have a bunch of chunks. You have a question coming in. The question is encoded into a vector. The documents are encoded into the vector using the same embeddings as the question, mostly. And then there's a cosine similarity that is sorted. And then you can pick the top k documents, and that is your retrieval process. What is the retrieval process with uh, this now?
Yeah, so like I said, this is also a bi-encoder model only. So bi-encoder models are the ones, like you said, they process the query and the set of documents differently, and they calculate the cosine similarity of it. So uh, that is how it's been done here as well. So like I said, this is just a retriever model. So the underlying pipeline you said remains the same.
We're
Just
also
that
giving
the
a vector, and then a cosine similarity is calculated.
cosine
Like
similarity, yeah.
the possibility is that they're taking a chunk, like they're directly they're taking the chunk, they're taking the query and directly giving a score. But you're saying these are also embedding models, kind of, that are embedding the query separately, embedding the document
Yeah,
separately, then a cosine similarity is calculated.
yeah, got me, correct.
Have you seen the retriever pipeline? Because that is also a very elegant idea, like why just give a embedding score and then create cosine similarity? Why not just directly give a score, but given that you have the document chunk and the question, give a relevant score from 0 to 1 on how matched these two documents are. And this
Yeah, so
particular,
this is so what let me rephrase the question. I believe so. Bioencoders, what they use is they they vectorize the query and the document separately. What you're
right.
saying is दोनों को एक साथ consider करके get a score, right?
Correct. For
So
example, they're anyways using a 8 billion model, like
yeah,
they're anyways using an LLM. So you could just have in their prompt, given the chunk of document, given the question, and then ask them to give a score and then train that LLM accordingly. Like, have you seen that architecture of retriever already?
that is not essentially, yeah, no, we probably don't do that because मतलब it is done in the re-ranking step. So re-ranking step is the one that you're talking about. That essentially there's an LLM in this case, Quen 2.532 billion.
Hmm.
It considers the document in question and the query together and gives a score that is used for re-ranking. But yes, you are correct that this can be used in the first step as well. Uh, Yeah, that can be done. But generally, there are two schools of thought. One is bi-encoder, one is cross-encoder. This is a bi-encoder case. In cross-encoder, like I said, the cross attention is considered, I believe, between the query and the documents. So time complexity wise, वो काफी slower process होता है, काफी time taking process होता है. But that is bound to give more reliable results. And essentially, what you are saying boils down to that only. Calculating the cross attention between the query and the document you have at hand. What these guys are doing, it's what generally is done in binary encoders is that it considers the both cases separately. It vectorizes them and it calculates the cosine similarity between them.
So the benefit of bioencoders then generally is that the embeddings are smaller and faster. Or basically
Yeah,
the
it is a Coco process.
correct. So the encoder in a bioencoder, or basically something that creates the vector for the document or the text, is smaller. But here, when we are already using a mechanism like Llama model of 8 billion parameter that has the easy mechanism to do cross attention, why not just leverage that? That was just one thought I had.
Yeah,
Maybe
I think that is one of the future directions of this research, and I believe the reason these guys have not done is just to set new benchmarks on the bi-encoder thing, like what the research they've pioneered that will help bi-encoders. Obviously, like you said, it will help cross encoders as well. But just to clear the stage for bi-encoder paradigm, I believe the guys have used not just explicitly an encoder model, but a decoder only model.
hmm, got it. And with this Llama 8, with this Reason IR based model, the output is a vector, I guess. So this particular base model will take the question or a chunk of text and then output a vector, a dense vector of certain
Yeah,
dimensions.
yeah, yeah, yeah. Suppose that everything is the same. Just the inbuilt model that is helping in the stage one of retrieval that is different.
So
That is this model.
have they sliced the Llama model to give us that embedding? Maybe they're just taking the embedding layers of it or something,
Yeah,
or
right. Yeah, right.
bit
We're
layer,
just taking the embedding layers of it. We're just taking the embedding layers of it. We don't let it pass through all the layers and finally to the
logit one, the
yeah
language head.
the LM head, right. So element is essentially a 131072 sized thing that gives the probability for each of the tokens in its possible vocabulary. You don't
Right.
want to give it that. You just want to give the query after all the attention blocks are processed.
So they're taking the penultimate layers output.
They're taking the penultimate layers out. Correct. Just the embedding is considered.
Got it. Okay.
And this NDCG10 is that मोटा मोटा समझा देता हूँ. Basically, you try to retrieve 10 documents and you try to the instance for normalized and how much you're able to retrieve. Okay,
Yeah.
so for IR evaluation,
NDCG is normalized discounted cumulative gain, and it's a
yeah,
very standard metric for search.
for retrieve, right?
Yeah. Yeah.
Okay, yeah.
Basically, it's
So
like, given that I just while we touched on this, so normalized DCG is a normalized version of DCG. DCG was, what is the gain that you are getting from a particular retrieval, given that you have human marked scores of how relevant each document is for the question. Normalized retriever is, what if you are also having the best oracle performance, like the best documents are presented top to bottom. What is the score then, and what is the score with what you're getting? So it's basically normalizing with the oracle DCG.
yeah, you can say that's what the normalizing term is for.
Quick question, guys. So, does this data belong to some specific domain like science, math questions, or from codes or something like
Yeah,
that?
I'll
Just checking.
you'll probably see it in the data. It is more relevant to the scientific domains. You'll see it in the bright benchmark as well. So as you can see here, in the subjects we have biosciences, earth sciences, economics, psychology, robotics, and all of it, right? So the gains that are
Okay.
being generated here are mostly in the scientific domain. And मतलब आप इसके application भी सोच लो. It's probably helpful in drug discovery, or consider legal cases where you need to fetch suppose where you need to fetch relevant precedents to a particular case in question. मतलब ये बस मैं example सोच के बता रहा हूँ, but yeah, in cases where
Something
such a lookup is
probably
needed.
something probably simpler, like if I have a web application and I want to develop an Android application on top of that, then possibly we can make use of these sort of uh, retrievers to fetch
Yeah,
relevant pieces from documentations and then build code accordingly. Possibly
that is
something
true. Yeah, that is a very good application that you pointed out, Sachin, I believe.
interesting. Thanks, Ishan.
Mhm.
So
Yeah, I
before
mean,
the results, they throw any light on how they're training as well, or like
like I
it's
said,
pretty
the training pipeline is just the usual contrastive learning pipeline जिसमें rack train होते हैं. Okay.
okay. So normal contrastive learning based on this.
Mhm.
They have the
तो
negative
वही
examples, positive examples, and they're trying to maximize the similarity between positive and questions, and they're trying to minimize the similarity or maximize the distance between the query and the negative documents.
yeah.
That is.
So
Hmm.
yeah, if you try to read the paper ना, the language of the paper is in such a way कि लोग वो data जो data limitation है currently that we have on the net, they're trying to address that using a good framework. So uh, if you read the paper, many times they'll mention that the synthesizer is the core of this project. तो
Hmm.
डेटा जनरेट कैसे करते हैं, और ये कैसे, this is domain agnostic, this is a domain agnostic method, so you can kind of use it for anything, just that the prompts have to be correct. और इन्होंने actually prompts भी declassify करे हैं in the appendix of the paper. I'll show you those as well.
Got it. And to Sachin's point, the documents that they have used so far are normal documents. Like any domain that those documents are coming from, the seed documents that they have.
No, it's not necessary that all of them belong to a same domain, and that is why you have to, and that makes sense as well, right? You want it to be generalized and robust, not just fixed to a particular domain. So the domains are all different.
So do they mention which domains they're coming from? Or
Yeah,
basically the source of the data set, the PDFs that they are considering.
yeah. I believe the seed documents that they mentioned are from. Uh, uh, I'm forgetting the name of the data set. I believe it was Massive Net or something like that. That has close to 1.3 trillion tokens. They're sampling a few of those, and उस पे उनका चलता है फिर.
Oh, got it. Got it. Okay.
Yeah, I think it's something like that. It's something like that only.
Cool. We can move forward.
Yeah, and the results that you see are the most exciting, and they probably show that uh, essentially the data that was chosen, that was mainly relevant to scientific and scientific mathematical and code based thing. So this is the Bright benchmark. So Bright benchmark is split across, I believe, 10 to 12 domains, and you basically have a score for each of that. Like I said, NDCG at the rate 10. Uh, And as you can see, if, OpenAI के native embeddings, Voyager के embeddings, Google के embeddings, the model is consistently providing a state-of-the-art result. And this is the final result that everyone reports, which is 24.4. And note that the 24.4 is not without the re-ranker or any query refining or anything like that. So मैं निशा के इसको correct करता हूँ. So you can see here, right, that the model that you use, if you try to refine the query, what I mean to say, suppose is that many times the query, the wording of the query or the intent of the query is not that proper. So you pass it, you give an LLM call and you try to refine the query so as to enhance its content and intent. So that is called as query restructuring. So you can restructure it with Llama 3.18 billion instruct, or you can do it with GPT-4. 3.18 billion instruct पे just इनको delta दिखाना था कितना delta आता है, and this is the main thing that is considered for us. So using what do you call it? If you restructure the query using GPT-4, the score jumps from 24.4 to 29.9 for the retrievers. What I mean to say is that if you enhance the query, retriever performance is अच्छे हो जाते हैं, and सबसे अच्छा retriever performance भी ReasonIR 8B का होता है. Okay, and with this, if you include the existing retrievers, which is BM25 and QueryRank, QueryRank basically explained in the previous slide was their ReasonIR re-ranker, which helps in breaking ties. If you try to include that, then the score jumps from 29.9 to 36.9. So this is a SOTA by a very big margin that they've accomplished here. So that is the reason that this is a very good paper for information retrieval, and I believe that this will gain much more traction in months to come. And
Were they using the base Llama 3.18B and rather than a customized one?
yeah, 3.18B base was used to the candidate model was 3.18B base.
There are two more things to appreciate. One is that evaluating with original query and evaluating with the reason query gives such a big bump. Like let's consider BM25.
Yeah,
The average was 14.8 and now it's 26.5 or 28, when even with Llama based. Oh, sorry, that was for ReasonIR. But for BM25 with GPT-4 reason query, it's 26.5. And that is for contriver model also, for grit LM also, for
exactly.
so first of all, one is that it's good to have a reason query. And I believe reason query is about just refining the input query and maybe, standardizing it better or giving the core components of it better.
That's correct. Basically, the information embedded in it is so much that the present retrievers are not able to, essentially ever effectively utilize that information in the retrieval process. So that is the reason. हाँ बोलिए.
Is reason query doing something different than just refining the query? Is it also laying down a plan for execution, or what is exactly is reason query elaborating?
So from what was mentioned in the paper, it just elaborates the query a little much. It just clears or polishes the intent of the query. That is all it does. It doesn't increase the number of tokens in it.
So basically, it's removing the removing the fumbles or removing the ad hoc things and restructuring the query better. Just basically
Yeah.
improving the
Yeah,
structure.
essentially just restructuring the query better to refine it. The word I'll use here is refine.
No, they say reason query, but otherwise, what we are saying is it's just query refinement. It's not giving a plan to retrieve the documents.
No. It's not giving any plan. The
Mm.
reason query here is to show is that existing models fail on reasoning based queries. Like I said in the first slide, these models are conditioned to, they've seen 2021 tokens average ka query. So when they see queries from Bright which are like 190 tokens of average, they're bound to fumble. So even if you try to enhance the query, enhance if you even try to give it little hints with GPT-4 and you try to refine it, even then the performance is not able to match what ReasonIR was able to achieve.
Hmm. Got it. The other thing that we are seeing is that um, the Quen re-rank definitely is giving us a much better boost. I'm just trying to see that reason IR8B versus BM25 is
This is a delta of 3.4 something.
right in the reason in the question in the part with reason query, but it's a much bigger delta when it is with the original query.
Is it the that just tells you how important query refining is, or how vague the description or how poor the initial retrievers are when
Also
you
that also tells that with reason IR, of course, you have a higher NLP capacity or capability involved, so it is able to do some semantic matching. BM25 is definitely a more text-based, overlap, lexical-based approach, so it's maybe picking the wrong words or overlaps, etc. So refinement is much more important there, but it becomes less important as a better refined query is coming in.
that is true.
Basically, the disadvantage of BM25 or those conventional approaches was with user queries that are not well formed. But if a well formed query is coming in, even lexical is able to perform quite well. The other models are not able to give that much of a delta compared to a conventional retriever.
Yeah, that is true. And yeah, if you see the the rank 132 billion paper that was released, that was addressed with a similar fact as well. That you pointed out is that BM25 or existing sparse retrievers or even dense retrievers, they benefit a lot from query restructuring or query refinement,
Correct.
right? And
It's
so,
so hard to beat the conventional stacks like BM25. Like they have been really powerful. I
yeah, and
know of the production search stacks are still running on BM25
BM25.
and GBDT rankers. Many
Oh,
production rankers, and there have been so much effort to replace them with ML-based models, etc. But some conventional technologies are still keeping the pie.
yeah, I mean, so the backbone of BM25, I believe, is TF-IDF only, right? So there are many
EFIDF
cases.
with certain normalizations on high frequency repetitions
Yeah,
and better words,
but
etc.
But the heart of it, all of them are sparse retrievers. They're not embedding based retrievers like, I mean, they're embedding based retrievers, but not dense embedding retrievers like
There's
the
lexical.
BERT or, yeah, yeah, right.
Yeah.
Yeah, that just goes
Girish,
to show how much value they carry even today.
Hi,
correct.
yeah, I just had a small question if I can ask right now.
Sure.
Yeah, yeah,
Go ahead.
Yeah, so basically in this particular paper, like we were just discussing that there is this synthetic data generation pipeline that is used, right? Basically, it's using LLMs to generate that particular data, and basically for the hard negative mining, basically it's using LLMs. So that's definitely
yeah,
way more effective, like obviously than the traditional mining approaches which don't use LLM. But like we were just discussing that can the traditional hard negative mining approaches still be useful? Like, can they be useful in any of the tasks? Because this approach is definitely like better, and it basically it's less error prone, and it's definitely way more precise as compared to the traditional approaches, right? But can the
right.
traditional approaches still be used in any of the cases or like for any of the tasks?
So I understood the question, Girisha. So uh, in the present system, what you can see is that uh, ये मतलब ये लोग hard negative generate कैसे करते हैं is that you give it a query and you just tell it to generate a complex query.
Yeah,
That is
yeah,
how that is what the existing systems
yeah.
work.
Yeah, yeah,
But what these guys observed, and I believe in the paper there was a pilot study conducted as well as these hard negatives are not so hard. They आगे जाके evaluation study आएगी. Many of these fall under the category of EQ, which are easy queries, which are not so hard negatives,
yeah,
but pretty much easy queries. So contrastive learning के time पे उतनी help नहीं हो पाती है. We wanted to we want to have a very fine line between the hard negatives and the true positives, right?
yeah.
So that is the aim here. So we try to in this case, the approach is much better. Like the outputs that you get are much harder to negate. So to answer your question, I believe since we have a better approach, the old approach should be the empowerment.
Okay, like basically for any of the tasks, this approach is way more better as compared to that one.
Yeah, because you see the heart of it, right? Instead of just giving it a document and in the
Yeah.
first prompt you tell it to generate a complex query, what you do is you let the context fill up with the understanding of that particular document and how some core principles and how the background of the document is, how problems are solved within that document, how is the complexity of the document. And once usko thoda sa idea mil jata hai, it is able to generate much tougher questions, right?
Yeah. Basically, when a deeper sort of understanding is needed.
Yeah,
If you
exactly.
yeah. Okay.
Yeah, and to today's LLMs, they have context lengths which are really high essentially. For you consider the Llama 3.3 70 billion instruct that has 32K, which can be scaled to 128K tokens. So आप कितना भी बड़ा document दे सकते हैं, and you can fill it up with so much useful information that the final hard negatives that you get are so good. That is
Yeah.
what they try to identify.
Yeah.
And I'll show you why they are so good. If you can see in the difficulty measure part, you can see that the hard quiz that you're generating, BM25, which like Ayush said, is so much used in daily search applications or in the enterprise search applications. It had an error rate of 53%. That is how difficult these hard queries are.
Yeah.
That means in every one out of two queries, your classic the document you are questioning at hand is a hard negative, meaning it shouldn't be there for a particular query. Similarly, for grade 7B, which is a dense retriever, BM25 is a sparse retriever.
One thing, Ishan, if they had given the error rate after the refinement, that would also have been very good to understand.
Error rate after refinement, could you elaborate?
After the
Basically, the refined approach, like I
after
think that's
the query.
yeah.
Oh, the refine. No. So, I mean, we're training ReasonIR with this data. So, I don't understand how you're meaning
Wait,
the error rate of this.
when you showed the results, there was also an approach of refinement or reason query, right? Like given the
Yeah,
user query first refined and then passed through BM25. So this BM25 error is on the raw HQ, MVL, and public one.
it is. It is. Yeah.
But this would be much less on a refined HQ and a refined VL.
Yeah. That is true. That is true. Oh, you want to see the effect of refining of GPT-4 in this case as well?
The effect is there in the results itself, but I'm saying that the error rate of BM25 would be much less when refinement is part of the pipeline.
Yeah, that is true. And you can kind of, so there's an ablation study. I have a slide of it at the end as well. So maybe from that आपको थोड़ा सा idea पड़ सकता है.
Right.
There's an ablation study where you explicitly consider just HQ, or just VL and just the public, which is the raw initial system. I'll come to that as well quickly. We are just 8 minutes away. So these were the results on information retrieval benchmark. Second is the RAG benchmark. For RAG, we use MMLU and GPQA. MMLU is a standard benchmark which is used by almost all LLM companies for showing what their models are worth. And GPQA, which is like I said, graduate level question programming, and this is Google proved. So again, two types of categories here. One is the original question, and closed book is basically you just uh, ask the model the question and you don't provide any additional context. That is what closed book means. And then in the second part of it, you have all the retrievers answering the original questions. And that you can see that in GPQA, they have achieved SOTA compared to Contriever. And similarly, if you try to refine the query with GPT-4o, I believe for query refinement in this case, the model that was used was, I'm not sure which the model was, but again, in MMLU, it achieved 75.6. Now, 75.6, I would like to iterate is a very good number for 8 billion models, considering the amount of data they've been trained on. MMLU is a very popular benchmark for LLM performances, and you can see that just by refining, we were able the model has learned already so much that the effect of reasoning is just 0.6 points. There's not much that you've gotten from it. So that is a very interesting observation here for RAG based benchmarks. That in fact, आप GPQA में देखो कि if you try to reason the query, in many a times your retrieval is falling down from 38.4 to I believe 35.4. That is a drop of 3 points. So yeah, that is I believe that is a very good insight that we have here.
Nishan, can you repeat this insight?
So just from the graph, if you see the MMLU column, you can see that ReasonIR bit आप original question दे दो और आप एक recent query दे दो, तो the delta is just a positive of 0.6. But which again is very less considering you're improving the queries. This just means that MMLU के queries are pretty much conditioned properly and they're phased properly. That reasoning then probably just the reasoning LLM, it probably miss out on some of the context that is fed to ReasonIR. So that is the reason the delta है. Delta इतना अच्छा नहीं आया. Similarly for GPQA, you can see that it went from 38.4 to 35.4. Like आपके reasoning करने के बाद you got a delta, you got a difference of -3. So
Ishan, GPQA is programming based questions, right?
Just a minute. Huh? GPQA is Google. I believe they're programming based questions only. I think they're graduate level programming question and answers, which are Google proof or something like that. Let me just quickly search it. I believe you're correct. Yeah, graduate level Google proof question answering benchmark. But that has questions in that is not pertaining simply to programming based questions. It is considered in STEM fields. Like the question contains questions in the STEM fields that are reasoning intensive.
So Ishan, this can be due to that this ReasonIR is trained on original questions, not on the reason query. So maybe
They trained on the original questions. Yeah, probably that is true as well. Maybe the data it was trained on, much of the data was probably leaked from GPQ as well. ये हो सकता है. Or maybe the question pattern that was considered here was. But अगर ये होता तो फिर वो ये वाला result नहीं दिखाते. They wouldn't have selected GPQ. So I don't think that is the case.
I have a question though. Like they mentioned, like MMLU and GPQA are like open domain, no knowledge sources task. So what are they retrieving on?
हाँ, आप देखोगे ना massive DS करके है. So massive DS is again a data store that has tokens crossing 1 trillion. तो उसका एक filtered version है. तो like आप अगर टेबल का कैप्शन देखोगे तो that they've written that they use filtered versions of massive DS. I believe तो उसमें से ये लोग fetch करते हैं. So many times वो क्या कर रहे हैं कि so वो 1.3 trillion tokens है. They're assuming it to be the Wikipedia of the world. And उसमें से they're fetching top 1000 or something like that documents. And that is the retrieval in this case. Generally जो results report किए जाते हैं वो उनमें RAG use नहीं होता है. Like जो भी models का आप MMLU benchmark देखोगे, it's completely closed book. It is based completely on the module's capabilities, not any external knowledge is put to it.
100%. And probably that is why maybe on their filtered massive DS, they don't have enough data to support GPQA because search engine is able to do better.
That is true.
But no, the data should be there because the original question is doing better. So that comes to suggest that the refinement is actually introducing confusion or bad query refinement.
If you see that Contriver, Grid 7B and ReasonIR, all are degrading when you refine the query, right? 36.4 से 31.3 आया, 32.3 से 30.8 आया. It's just the search engine that has witnessed a delta.
Right.
But that's only on a certain benchmark. So it might be the case कि GPQA के cases में जब वो refine कर रहा है query को तो hallucinations introduce कर रहा है.
I also think the refinement prompt is not working for this GPQA.
This particular benchmark.
You can see, right, for GPQA in the caption, they're using 2.57 billion for query rewriting. So yes, maybe you can the output that you're getting in the refinement is not so refined. That must be the case.
Yeah.
But again, ये कोई reason नहीं है कि search engine का बढ़ क्यों रहा है.
मतलब could be थोड़ा random. I don't know.
Yeah, this must be little random. But then again, the guys
Google,
who publish this,
Google does its own stack of refinement, etc. So maybe it is able to still find the right sources. And maybe it has a massive DS available. So even with those hallucinations, it's able to find a relevant document to answer. So maybe refinement
might be the case.
Refinement is making retrieval bad.
Yeah,
But that is on massive DS. With search engine, you don't have access to massive DS.
probably. Yeah, I believe that is the case.
Yeah, you have much better data sources than just massive DS. So that is what is happening with GPQA.
That is a good explanation. Hmm. Yeah, I mean, so results wise ये दोनों ही थे, एक एप्लीकेशन स्टडी फाइनली थी जो मुझे कवर करनी थी. How the effects of it are. So a normal llama it भी just gives 9.5. आप उसको पब्लिक कॉन्टेक्स्ट पे फेच करो, जो पब्लिक दैट वाज 1.3 मिलियन सैंपल्स, देन यू जंप फ्रॉम 9.5 to 19.6. You add about 100K hard queries, you jump to 20.9. आप अबाउट 300 के वेरिड लेंथ क्वेरीज डालते हो. इससे क्या होता है, सो कॉन्टेक्स्ट लेंथ इंप्रूव हो जाता है. सो even in the public set it is able to handle the varied length or high token high token length queries much better. 20.9 से 23.2 आता है. और इसके बाद का जो है वो स्टेप इंपॉर्टेंट है कि पब्लिक प्लस वीएल एंड पब्लिक प्लस EQVL में बेसिकली आप उसको EQ इंजेस्ट कर रहे हो, उससे 23.2 से वो 22.3 आ रहा है, विच इज बेसिकली कुछ उसको परफॉर्मेंस इंप्रूवमेंट नहीं मिल रही है, नॉट इवन कांस्टेंट परफॉर्मेंस इज डिक्रीजिंग. तो टू टू गिरीश, आपका जो पॉइंट था कि अर्लियर वेज जिसमें ये EQ वो फेच करते थे, अभी आई मीन यू कैन काइंड ऑफ सी हियर राइट दैट कि उससे इतना डेल्टा नहीं आ रहा है. इन्होंने जो हार्ड क्वेरीज फेच की है उससे बेटर रिजल्ट आ रहा है. वी आर जंपिंग फ्रॉम 20.
जिसमें इन्होंने LLM वगैरह यूज करा है उससे बेटर आ रहे हैं, मच बेटर.
या एग्जैक्टली. तो 23.2 से 24.4 जा रहे हैं, which and I believe कि existing cases में it went from 23.2 to 22.3. तो अब डेल्टा निकाले जाएंगे तो effectively 2 का डेल्टा है in DCG. And again, if you refine it with GPT-4, you can see that the refinement works greatly, and we jump from 24.4 to almost 30.
Yeah.
In the final variant.
Yeah. Okay.
It's interesting कि coding and theorem-based questions में refining actually degrades the performance.
That just means
lead code and
yeah.
But on
I mean,
yeah,
that is true. Consistently, so I believe that has to do with that should probably have to do with the hard queries that we're generating. The effect that is the ये जो डेल्टा आ रहा है, I believe ये डेल्टा मेजरली हार्ड क्वेरीज की वजह से आ रहा होगा. क्योंकि आप ये देखो कि 34.5 अगर आप सिर्फ वेरिएड लेंथ यूज कर रहे हो तो वी आर जंपिंग फ्रॉम 34.5 to 34.7. So you consider that as constant. But the moment you add hard queries, ओवरऑल परफॉर्मेंस नीचे गिर जाता है. तो आप जो फाइनल पे जाओगे पब्लिक प्लस HQVL और पब्लिक प्लस HQVL यू जंप फ्रॉम 35 to 31.5. सो आई
मतलब रिफाइंड वर्सेस नॉन रिफाइंड में लामा 3.18B जो बेसिक है एकदम, उसका देखें तो बहुत डिग्रेड हुआ है परफॉर्मेंस. 22 versus 6.8
is on the DS. The data store maybe because you see for coding the lead is degrading, the pony is improving. So it's basically the massive DS that they have, the data source that they have.
यहाँ massive DS नहीं है. यहाँ I believe यहाँ Bright में massive DS नहीं है.
तो फिर they must still have a data source, right?
हाँ Bright में ऐसा है कि given a query they have a set of documents.
हाँ, अच्छा. So you're saying relevant documents are available for both lead and pony.
But still, that is no reason that the performance should drop so much from 22 to just 7. That is a very big.
It is improving for public. For data.
Bio, earth sciences, economy, and so on, the performance is increasing everywhere. But for coding particularly, and even for theorem-based questions, नहीं AOPS dataset पे ये पता नहीं, मतलब it's a bit weird.
I think आप इसका delta देखोगे, इसका delta is much more evident in the stack exchange part of it. You know, the biggest delta you're receiving is from. So yeah, probably that is again a more important thing is that coding में it is not always that refining will help.
But by any chance, do you have any idea कि ये lead और pony datasets में क्या difference है fundamentally?
Lead तो probably lead code ही होना चाहिए.
हाँ, pony क्या है? dataset क्योंकि इसमें बहुत अच्छा चमकता है यार.
But it's probably like if we just look at the data, it's probably the refinement is not working well enough for those query problems, and then maybe the data set is also.
The reason I'm asking about the data set is because it might help us figure out कि किन type के cases में refining the query can actually degrade the performance. That can be significant for companies that are using LLMs to develop enterprise applications, because most of these companies are actually using query refinement as one of their pivots in their pipelines. So,
Right. Let's Ishan, let's look into that and discuss that offline.
Yeah, that is true. Yeah, so guys, from mine, that is all for this paper. I believe कि इसके applications काफी ज्यादा हो सकते हैं. Like I said, मुझे एक law वाला तो काफी अच्छा समझ रहा था, but उसके अलावा भी, I mean, if you guys come up with like, even in medical discovery, or for complex patient cases, case studies that we have, essentially for any complex case study, this is relevant in the primary research part of it.
Cool, perfect. Thank you, Ishan. Guys, I know we are out of time, but we can take quick questions if you have anything.
thanks, Ishan. This was really helpful.
Cool. Thanks, Ishan. And yes, thank you everyone for joining. Thanks for the engaging discussion. And then we'll post the next research jam on the channel soon. And looking forward to meeting with you all again. Thank you.
Thank you, guys.
Good night.
Hi, Ishan. Good night.
Yeah, thank you.